Ranjith Singh. He's a seasoned cybersecurity professional and networking professional as well, with 17 plus years of experience, currently working as senior principal security engineer at Fortinet Technologies Private Limited. Previously, he worked with various product companies like Cisco, Nokia, and Ericsson. His expertise in web and API security, network security, pen testing, automation. He has a diverse experience in various products like routers, switches, next-gen firewalls, WAF, DAS, SAS, and multiple tools. He is a CISSP certified professional. He is exploring AI security and AI for security recently. This will be a very interesting session like the previous ones. Please give him a big round of applause and welcome him. Please, Ranjith. Yeah.
The previous two speakers were against AI, so they were telling there are a lot of risks with AI, and they are like preaching about like what we should do to protect AI. I mean the security risks caused by the AI. So I will come up with something different. Yeah. Right and left. Okay. So I'll have to like so what I'm going to explain about is like how we can use AI for various security purposes, like how we can build tools for security using AI, which can help reduce the human effort, like and increase the productivity. So that is my perspective. I mean my presentation about. So already the introduction was given by. Okay. AI agents. So agents are something which actually they are just software applications which can help they can make self-directed decisions and achieve certain goals. The goals are being set by the users, but the approach and which tools to use, what kind of external environment to it interacts with the external environment and uses whatever tools and so it has a ecosystem where it can connect to different tools and take the data and then helps the user to achieve that specific goal. So LLMs are the brain of the agent, and so it can also interact with external tools, data, resources, and then achieve the tasks. So yeah, you can see here agent, it has a memory so to process the information and store the information for longer term purpose, and it has access to various tools. It can be coding tools, API calls, and whatever search tools, everything, and it can take autonomous actions. So there also there are many cases where we are not still there yet, where the AI can be considered full 100% effective and safe. So human in the loop is also a part of this thing. And so an AI agent can also have like multiple sub agents, so it can delegate tasks to other agents and then achieve the task. So yeah, so how it works, so it determines the goals, and it understands what sort of information is required, so and then connects to the necessary tools and then achieves the task. So there are different type of AI agents. There are simple reflex agents, which is basically just a rule. They just use for simple tasks. They just have certain rules, and like you just have to program a firewall rule for a specific condition like that. So in those kind of things are simple agents. So model-based agents they have certain internal model, like they maintain a state, and then so they understand what is the probability of action, and then so they take decisions accordingly. So those are model-based agents. Goal-based agents are again like they have certain predefined goals, so they can take any actions and then achieve that goal. So the task is to achieve the goal. So learning agents are something like for example, you can think about like self-driving cars, or like personal AI assistants, which understands the user preferences, learns from them, and then tries to improvise that. So they have some reinforcement learning and those kind of mechanism, and then achieve the task. So there are different kind of frameworks for building agents. So these are some of the popular ones. So there is LangChain, which is which is kind of like an ecosystem and has a lot of libraries, toolkits for building AI agents. LangGraph is an extension like more for building more stateful agents, and you have like small agents from Hugging Face which are used for simple tasks like and you have Microsoft has certain frameworks which is semantic kernel and autogen, which are more for like enterprise use cases, and you have Crew AI which is more for building collaborative AI agents. So each one has its own strengths and weaknesses. So like LangChain is the most common. LangChain and LangGraph are very common because they have a very good ecosystem and there are a lot of libraries and tools for this thing. LangGraph is mostly for stateful like multi-actor and like multi-agent systems can be built using LangGraph. So these are the popular agentic frameworks. So like when we talk about LangChain, so this was like very initial stages of AI agent development. This has come from like this has been in the industry for a long time. So they have like a lot of tools. So basically the main advantage is like if you have to write boilerplate code to build an agent, so it will take a lot of lines of code. You have to write a lot of so every tool and every utility. You have to create functions on your own, but this LangChain has so many libraries of built-in functions for various tasks, like whether it be web search or whether it be like communication, like interacting with Gmail, Slack or something. So all those things are pre-built functions are available. So that is one thing, and also it acts like an abstraction layer. So you have so whatever LLM provider you want to use, whether you want to use Azure OpenAI or you want to use Gemini or you want to use Claude AI, so any type of provider you can use, they have like certain pre-built functions so that you can easily switch between the providers. And also for data integration, like so they have so many tools to connect with, so like for building a RAG, you want to upload documents and build embedding, like use embedding models, and you want to connect to different databases like for that, so like SQL databases. So for that they have the tools and like vector stores. So vector stores are basically the embedding this thing, so where your data is converted into embedding so that it can be we can do a semantic search for through that. So that is one thing. And also it has something called Langsmith, which is more of a observability platform. So let's say you are building a multi-agent system, then you need to understand what sort of communication is happening, and if you want to debug that, and what sort of cost is incurred, like how many tokens are being used. So to understand all that, to debug that, so you have Langsmith. So these are the key features which I already explained. So I'm not sure if this picture text is visible. So whatever I mentioned, so it's input processing, you have embedding, so you can store your data in vector DB, and you have the retrieval mechanism, and you have the orchestration where you have the agents and memory, and so that's about it. Like and the chat models, the LLM models, whatever you can interact with. So the models, tools, agents, memory, retrievers, and document processing. So these are the things. So just these are simple like flow. Like if you consider a RAG agent, you have a user question. So you have a vector DB which contains that specific knowledge base or information. So then there is a retriever agent or a mechanism which will retrieve the docs, and it will pass on that through a LLM, and then it will give you an informed response. And then you can like build agents with can connect to different tools. So if you have a question or you have a ask, then the agent decides, okay, whether I have to connect to some external tool. It decides that, and then whatever the tool, the response from the tool, it processes that and give you the final result. So this is just a simple the function, like how you can invoke the model in LangChain. So you have a LangChain chat models, and you just give a model.invoke. You can specify what is the temperature, what is the timeout, the tokens, all these things you can specify. So all this, I think the code may not be visible for everyone, like maybe you can later refer the slides. So like I said about the toolkits, right? So they have so many different, like for example, web browsing, you can use a DuckDuckGo tool, like there is Tavily, and like if you want to search in Wikipedia for some content, there is a wrapper for that. If you want to use any and if you want to like automate some UI tasks, then you can use a Playwright toolkit. And for productivity, you have Gmail, Calendar, GitHub, Slack, all these toolkits, you have libraries for that. And so this is just a simple example where you import the DuckDuckGo search tool from the LangChain community of tools, and then you can search for the latest CVE, like and then you get the result, process that and get the result. So this is for the inbuilt tools. Like if you want to define any custom tool, like you can also define your own tools. You can have like so this is a simple Python function where you import the LangChain tools module, and then you use just a Python decorator, and then you which is add tool, and then you define whatever function you want. So this is a simple function which just sends a Slack message using a webhook. So likewise, you can build any custom tools you want. You can define your own functions, and then you can invoke it from the agent. So this is a document loader function. So you have in LangChain community, you have a document loader where you can load your PDF, and you can process it. And then this is a text splitter where so if you want to process if you want AI to process your document, you have to split it into chunks and then store it in a vector format, like in an embedding format. So for that also you have necessary functions. So this is like a RAG, how a RAG works, like a simple architecture where you the user asks a question, there is a framework and there is a vector DB, so which has the contextual data. So there is a semantic search happening, and the LLM does the post processing and gives a result to the user. So again, this is a simple RAG based agent where you have the functions imported, you are loading the document, and then you have a system prompt which defines what that agent has to do, and then so the user so this is how a simple RAG agent can be created by using LangChain. Next I will talk about one simple use case. So where like we would like to build a simple agent using LangChain which can dynamically create Snort rules. So Snort is something like an open source intrusion prevention and intrusion detection system, which is very common. So it's an open source tool. So it has different modes like sniffer mode where it just listens to the packet, and logger mode where it logs the packet information whatever it is there, and if it is in a nits mode, so you can block the packets whatever you want. So there are Snort rules which can be used to raise alarm in case of any malicious or suspicious packet is received. You can so that is done by the Snort rule. So you have this this is how a Snort rule looks. So you have a rule header and a rule option. So you define what action it needs to take, whether it is alert or drop or anything, and you have this protocol. You specify the protocol, the source and the destination, and also the port details, and then you can have a option like which tells what this rule is about, and you have the ID for that. So there are different type of Snort rules like alert rules, block rules, which is and drop rules, and you can also create specific rules for matching the file types, like by inspecting the packet and looking for any malicious files in the packet, like it's a exe file or some kind of thing. You can look for the magic numbers in the file headers, and and you can do some analysis. And this Alien Vault OTX is something like a very common like OSINT platform where users can search for like a lot of data. There you can look for, like if you have some IP and you want to know whether it is malicious or not, you can look for it in OTX. And if you have, like let's say you have a domain or some file hash. So you want to know whether that file hash is associated with some kind of malware. You can look into it, and then so because that is a community where all the users upload that kind of information, so you can search for it. So whatever data you want to know whether it is malicious or not, you can search for it. There are pulses which is created by the community, and then you can confirm whether that IP or domain is malicious or not. So this is a simple LangChain agent where you can just extract from your PCAP file whatever IPs, domains, file hash, any information from that, and then you have a tool called to an Alien Vault OTX platform. So you have an API for that. So you create a tool, you create a tool definition for that, and then so you pass it to the Alien Vault OTX. So based on the analysis from OTX, if it is malicious, you can create, if it is malicious or suspicious, then you can create a Snort rule for that. So the Snort rule is again like created dynamically. So there you have a tool call for that. So all this is done by like you have a LLM like behind it. You can use any LLM. You can be a locally hosted LLM in your own data center if your company has it, or you can use in an enterprise license like an Azure OpenAI based LLM. So this is the simple code for that. You have just a build agent function. I'm defining the LLM where I'm defining the Azure endpoint, the API keys and everything. And this tool calls, like you have the OTS IP lookup and the generate Snort tool. Those are tools which are part of the agent which I have defined. And then you just invoke the create agent function. So it is as simple as that. You just have very few lines of code and you can achieve different things using that. So this is just a Streamlit UI where I'm just uploading the packet capture, and then once the capture is analyzed, so the okay, this is the IP, so it the LLM analyzes it, it invokes the necessary OTX tool call and says okay, this IP seems to be malicious, so I will create a drop rule for that. So this drop rule is created. So this is one thing, and this is somewhat suspicious. It's not actually malicious. This is based on the number of pulses, the reputation score and everything. So here it is considered to be suspicious, so it is creating an alert rule. Okay, let's monitor it in future and later we can check it. So that way. So that is for the LangChain agent. So now let's say you want to build something more complex. So for very simple use cases, LangChain is good enough, but if you want to build a more complex application, let's say you want to do a complete end-to-end pen testing, or if you want to complete end-to-end red teaming, which is a very complex process which involves only so many different processes, like you have to do the reconnaissance, you have to do the payload generation, you have to do the initial access, and then you have to have some create some thing for persistence, and then you have to do lateral movement and so many different things. So in that kind of complex application, it cannot be just achieved using LangChain, so you need to go for LangGraph. So the LangGraph has so the state concept, and it is like basically a graph. So you have nodes and edges. Okay, so you have nodes and edges. I will come to that slide later. So you have a state concept, which is like a shared data structure, which stores the current information. I mean current status of the agent. So whatever information, the current, what is the context, everything is stored in the state. And you have nodes. So the nodes are the actual functions. Like it can be similar to like tool calls. So it can be the actual Python or whatever code you write. So the functions which does the task, it has all the logic involved. Then you have edges. So the edges are the connections between the nodes. So you can have like conditional edges. So where you can decide which node to take. So let's say you have a graph, like you can have many number of nodes. You need to know, okay, like for example, you consider a red teaming agent, you have done some reconnaissance, and these are the services and these are the ports open. So then I have to call this particular tool, I have to go in this direction. So that is done by the conditional edges. So you define that conditional edges and you then choose the next appropriate node to take. So that is the advantage of using LangGraph. So you can see you have a start, you have a node, and then you have a conditional edge. So you can branch out, you can choose which node to go, and then so based on that the further actions are taken. Again, this is just a sample code where you are invoking the importing all the LangGraph later libraries, and you are creating the state graph, the edges and nodes. And so I'll also explain about this thing. So you have like LangChain, LangGraph. I already told about the difference. So LangGraph is mostly for it's like an orchestration platform where you can build multi-agent systems. And you have also LangFlow. So LangFlow is something which is like more of a visual prototyping application. You can create agents easily. You have all these UI elements and you can build agents easily. And Langsmith also, which I initially mentioned, so that is used to monitor the agents to understand how much is the token usage. You can trace the calls, what are the LLM calls, what are the tool calls being made. You can trace the agents working and debug it. So that is done by the Langsmith. And so memory is important. So you have a checkpointer function. You can you have a long-term and short-term memory. So if it is within a single conversation you want to store the data, then you use a short-term memory function. But if you want to have like between multi-agent systems or between sessions you want to store the data, then you go for long-term memory. So those are all already part of the LangGraph framework. And there are more advanced concepts also, like threads and like super steps, so checkpoints. All these things are kind of little advanced concepts when you have to build multi-agent systems. So this is another example use case. You can see like this is a LangGraph based WAF rule generation agent. So you can let's say you have your web server, right? You have Apache or Nginx, any web server you use. You have a lot of logs to look into, so you don't know what sort of malicious activity is happening. So it is very difficult to be done by a human. So if you want to actually leverage AI, if you use AI to monitor and analyze the logs and build dynamically the rules, WAF rules for you, it can make your task a little easier. So you can, like, there are different tools to analyze this thing. Like for example, you have Zeek, which is kind of like which gives very detailed information about your traffic, and then it passes and gives you the different URI or whatever the headers, everything it gives, user agent, everything. So you can pass that data to, you can pass that information to the LLM, and then you can analyze, you can look for certain specific patterns, like you can look for malicious user agents, malicious headers, and malicious the parameters, the query parameters in the URI. So you can analyze that, and then based on that you can build your rules, you can build your WAF rules using that. So Mod Security is an open source WAF which can be used. So you can create Mod Security rules based on the analysis of the packets and the web server logs. So based on the analysis you can create the Mod Security rules. So this is again like a Streamlit UI I have created, and so it is giving analyzing the logs which I upload, and then based on that it is giving certain rules. So like if you ask whether Snort or Mod Security, doesn't it have existing rules? It already has a lot of community rules, and there are a lot of existing rules available. But the thing is how the attackers keep evolving. They use AI, they use more sophisticated mechanisms to trigger the attacks. So if you want to understand those more advanced patterns and build rules dynamically, then this kind of AI based thing can help. This is another example like where you can create a phishing campaign. Like you can this is more like for a reteaming exercise if you want to do it within your company, or so you can do a target profiling, which is based on their social media or whatever. You can analyze the information, publicly available information. Based on that, you can create your campaign. You can build your content for the phishing campaign. What is the mail you want to send? What is the kind of content you want to, based on the whatever data you have. And then you have like various open source tools, like you have GoFish, EvilJinx. These are kind of tools to know send the campaign and then analyze, so it can extract the information, whatever the session cookies and everything. So that is something which is like a use case. So this is a red teaming flow. Like if you see, this is a very complex and involves multiple steps. You have reconnaissance, you have weaponization, and you the delivery is done through phishing or other kind of mechanisms. And then you have exploitation. So once you get access to the system, you try to do some privilege escalation, and then you try to do lateral movement where you get into the network of the victim, and then you try to exploit other machines, and then you try to exfiltrate the data. So you exfiltrate the data, and then you also have to make sure you are not leaving any traces or logs, so for them to find you. So this is more like a complex thing. So this also can be achieved, like so we don't really have an existing agent which does this completely, but at least parts of it can be done through the current LangGraph or any other kind of agent framework. You can build it if you want. Like you can experiment with these frameworks. You can build, like you can have a record node. So in the record node you can have like different tools. You have Nmap, you have so you want to do some technology profiling for a website, you can use Vapalizer or some kind of tools to understand what is the technology, and then you can do the crawling to identify the endpoints. So there are different open source tools available for that. So you can have one node, or like you can create one sub agent, or you can have a node for this reconnaissance purpose. So once that is done, you pass on that information to the payload generation agent. So payloads, you can be like done through different tools, like you can use MSV Venom, like Metasploit. You can use Nuclei templates. If it's a web-based application, you can use Nuclei templates. And there is Silver C2, like you can, there are some libraries for generating web shells dynamically. So those sort of payload generations can be done through a node. And then you go through the exploitation. So then you can have like different agents for lateral movement and other things also. Those are little complex to achieve, I would say, because there are a lot of unknowns in that. So there is not a perfect thing for that, but at least part of your manual effort can be reduced if you use agentic framework. And then you can do the analysis and reporting. So LLMs are very good in that. You can summarize the information. If you have a lot of data, and then you need to summarize and then prepare a report. So doing that manually is always a boring job. So that can be done through an agent. Like you can have this thing for that. So this again the sample code, and this is LangGraph. I can probably Langsmith. I can show how it is. So this is the demo tool which I showed. Like it analyzes the packet capture, and it gives, like it says, okay, these are the IPs which you have shared, and so in that this is the malicious kind of IP. So I'll create this Snort rule for that, and this is like okay, this is malicious, so I'll create a drop rule for that, and this is something suspicious, so I'm creating an alert rule for that. And this is Langsmith, where you have like you can do all the tracing, like you have the different graphs, like you can trace how much is the latency for the LLM calls, what is the error rate. So this is the LLM call, and this is the latency, okay, how much time it is taking, and also the cost. So how much cost would consume, like okay, this is $0.2, $0.02 for some one application, the cost per trace, everything it gives you. So this is the output tokens, like how many output tokens, how many input tokens. and like what is the cost per tool, everything. So a lot of detailed information can be got from this. And there is also like a tracing where it gives the actual calls to the LLM. Okay, I think there is some network connectivity issue. I am not able to load it. Like, yeah, that's about it. And this is something called Langsmith Studio. So this is again like some kind of visual platform where you can build agents easily. So like where you have the tools, prompts, everything, and you can it gives a easy visual ability to drag and drop the things, and you can create the agents, the workflow. So yeah, that's it from me. Like if you guys have any questions, feel to ask. Sure. Yeah.
So all the things that you showed in the demo are single agents?
Yes, yes, that is single agent. Single agent.
But they are all small nodes, right? Like each one.
Yes, yes, yeah. So
what happens if there is a lot of nodes? Like is there going to be ambiguity in choosing a specific workflow?
So yes, there can be challenges to have, when you have multiple nodes, when you have building a complex agentic workflow, there can be chances of hallucination or agent doing some incorrect task. So that is why I initially only mentioned there is always human in the loop required. So we are not still there yet where you can have 100% accuracy. So there will be challenges. And also like as the previous speakers mentioned, right, like now when you have to use all these sort of agents, when you have to build it, there's a lot of data. So when this data is going to be exposed to the LLM, there is again the data security risk as well. So those are again challenges. So that is why it is always recommended to have your local fine-tuned model for specific use cases. So most companies are trying to adapt that. They are building smaller models specific for their needs instead of using the very large models. So for example, Cisco itself, they have their own security model, LLM model, which is built for security use cases. You can find that is available in Hugging Face. So likewise, so you have to so define what is your context. You have to, so there is a lot of the design things. You have to take care of the security. You have to keep the models and data local, how much ever possible. So that way you can minimize that kind of ambiguity.
So I understand that we can take it, break it down, that workflow into sub-agents as well.
Yes, yes, yeah.
But then when we do that, now we add extra latency, right? Because I understand that breaking down would actually keep the context free for the instruction for a specific agent. Now, but there is a latency increase, right? Because you are trying to, first is that find the intent, find the agent, send that instruction to or that message to the specific agent, and that agent is trying to now analyze and then talk to the LLMs, get the response back. Once that response came back, then again it will come to the orchestrator agent. The orchestrator agent has to infer the data again, right? So the latency is getting added.
Yes, yes, of course. But you have to again think about the practical thing, right? So same thing, can you compare that with the actual human doing it? So is that going to be much faster, or this is going to be faster? So that's where you draw the line. Like you can definitely See, there can be cases where you need to do a certain amount of review. There is some amount of analysis, human analysis required, where these kind of multi-agent or whatever the agent things may not work. But if you consider certain automated tasks, for example, like example I showed the log analysis, where you have to pass through huge number of data, and if a human going to sit through and go through all the logs and create the rules, that's going to be a lot more challenging and time consuming. So that for that purposes you can build smaller agents which can accomplish this task. Again, you will have to review, so you cannot just blindly you pass on all the data to the LLM and whatever rules it gives you cannot directly apply it in your appliance. So you have to review it and then apply it, but at least it minimizes the time consumed for analysis purpose and then creation, like that part it is minimized. Then only just to review it will take less amount of time. So that is how you have to approach.
I hope I'm not taking other people's question time. Anybody has, please. If not, I'll follow with some more questions. Yeah, okay. Just a quick follow question would be that how do you handle the memory, right? Because now you did talk about that you can try to give that memory to the agent, which is going to solve it. So something happened in the morning, an event exists, but then my memory is so big, just left that part, which was actually a signal that should have used in order to stop some of the intrusion, let's say. Now, if it misses that, then how do we catch this event that is occurring again? And how do we stop it?
Yeah, so that's how, that's why you have this kind of debugging tools like LangSmith, so which you can trace each and every LLM call, the human call, the tool call, so everything can be analyzed. It gives detailed calls for each of them. So you can see, okay, where it has broken, where it has failed. So that sort of that is why you need such kind of tracing tools. Otherwise, it's going to be difficult. You have 10 different agents doing 10 different tasks, and it's humanly not possible to monitor them and look into such kind of issues. There can be sometimes misinterpretation of data. There can be some invalid tool calls. So then you will know. So you have the tracing. You can look into, okay, instead of calling this particular tool, it has called a different tool incorrectly. So that is incorrect. So then you have to look into your code and then try to fix it. Like, so why that logic went wrong? Whether it is a issue with the model, then you have to see how you can fine tune the model, provide more contextual data, train it, and then use it. So that way you have to improve your agent. So it's not fully accurate currently. Like, there are a lot of challenges. So I agree, but that's how we have to go through. Like,
yeah. You teach the agent to do that.
Yes.
And thanks for showing the small models. I think small models are the way we can build agents. Thanks.
Thank you.
Just one quick question. This, I want to apply this on lots of these IoTs. What can be the best approach if you want to? Because if I want to apply some AI agents on top of it, so they're constrained on resources, right? Whatever is captured from the sensors or devices.
So you're asking about how you can apply agents for IoT security?
Yeah, in terms of edge, or you want to apply kind of performance there, or as a broker really. So what is the best way of taking that to the agents?
So you mean you want to take data from IoT devices?
Yeah, take the data from that and then probably process something for like the weather forecast, or in terms of agriculture to the farmer if I want to agents and then transmit some data in a kind of.
Yeah. See, that's what that can be done, but you cannot do any processing in the IoT devices. They are obviously very small embedded devices, so they will have very limited resource usage. So the data has to be externally, sent through APIs or whatever mechanism we have, and then processed centrally, and then the actions has to be taken. So only the action what needs to be done can be transmitted to the IoT devices. You cannot do anything there as such. Yes.
My query is, like you spoke about Snort, which is the agent built for IDS, IPS kind of activity, right? So whatever I know on that domain, like traditional IDS, IPS were signature based and were replaced by NDR, which was earlier called embed, primarily because NDR embed was a AIML based solution. So why we are going back to the future and doing again a IDS, IPS thing when we have our NDRs?
No, see, so the next gen firewalls or next gen WAFs already have some ML mechanism in that. Okay, so they are again using some sort of AA in that. But like when you have to build something, like again, those are all enterprise solutions which are at the time, like they again charge based on that. But if you have some like if you are a smaller company and then you have to build with open source things, then you can use such sort of solutions. Yeah.
Not a substitute for.
Yeah. See, you have like all like Palo Alto or Fortinet, all the NGFWs, they already have some ML mechanism for that. The WAF also has that. So yeah, this is more for smaller companies and which want to build with open source base. Like you have Suricata, your Snort. There are very open source tools, right? So if you want to use that and build your own security infrastructure, but you want to make it dynamic and more efficient, you can go with this approach.
Hello, hi.
Yeah.
I'm working in OT security. So I have a specific question to OT security. So suppose I'm working with some engineering operation. I have engineering workstation. So in engineering workstation, it is like doing some program change or program transfer operation. Okay. So in that context, like today I'm working for some specific work. Tomorrow I can work on some different tasks. So do you think that how feasible we can train all the data to AI? One question, because we have so many action per day. We have to open that wall today, maybe this time. Tomorrow we have to do certain action because it is like a very dynamic environment. And the second question, suppose maybe like I'm working with the Rafael, Siemens, all those PCS right now. So in that situation, if I take any PCAP file, and I'm analyzing with the Nojumi solution or any solution, and so that time I'm using the AI, like a public open AI, but obviously you know that user, credential, everything is involved. So do you think that if I use AI in future, so it is like ethical or it is like exposure kind of thing to our organization, like how we can prevent all those things? Obviously it will add the value, like if I have to analyze the PCAP file, so manually I have to search all the things. But if I do the what you shown log and all those things, so it will generate the things in very easy manner. But the second thing, it will expose all the credential, all those things. So
Yeah, so that is something. So always we have to use guardrails, and when you talk about data, you should not feed all the data which is personal, like emails or whichever is more sensitive data, that should not be fed to the AI directly. So there is something called anonymization or pseudo-anonymization. So always before you pass all the data to the AI, there should be always anonymization being done to minimize the risk of any sensitive data getting exposed. That is one thing. And when you talk about OT security, like you said, you have very dynamic and different set of things, tasks and activities to do. So that is something like there is a challenge. Like when you have sometimes, like let's say if I want to, like AI is being used for a lot of coding tasks, but if you want to build a website, you want to build a Flask app or whatever, it can be done instantly. But let's say I have a router, a legacy Cisco router, and I want to do some bug fixing in that. So it is going to be very difficult to train the AI to do that. So those sort of legacy systems or solutions where you have where the data cannot be directly fed, or you have some very ad hoc tasks. So those kind of things are still challenging. We are not there yet where that can be accomplished using AI. That's why we still have jobs. Like if everything can be done by AI, like we'll always.
Hi. So the solution was so nice. The use case of what you are showing, it's already available mostly. Okay. But I just giving some feedback for everyone. So how would you pivot this solution as as a security assurance solution? Okay. So already there is a Gartner framework called mesh architect. Mesh architect nothing but you have to each and every solution have to speak internally. Your endpoint security will speak to the network security have to speak to the AI. So when we have this kind of centralized solution, which will help you to bring the security assurance and post of your organization automatically and bring the automated moving threat defense. Okay. Basically the solution is automated moving threat defense framework. It's going to bring that baseline for the entire infra. Yeah, that's what. You've been giving us discussion of one simple solution, but we have to use it in the mesh architect solution, then it will be great.
Yeah. So that overall AI governance and framework is definitely reader. This is mostly to show a demo of simple applications. Whatever Snort rule I showed, this is very simple and it is already there in the community rule set. But what I am trying to explain is how it can be applied. So if you have to build like more complex things, like where you have to analyze a lot of file data or hashes and those kind of things, and you have to create dynamic rules, then you can use AI. And again, like you said, you have to have like a connected thing where you have the governance and what sort of data is going to the AI, that needs to be monitored. That I agree. Yeah.
Good solution.
Yeah. Thank you.
Any other questions? No other questions? Yeah, then.
Thank you.
Thank you. Thank you, Ranjith, for your wonderful session. Next, we have Ankit. He has written a book, AI Security, and he wants to present. Ram sir.